Hey class, hope you're all doing well. I want to make this short video on this class that we're working on. I assigned this problem earlier this week, and it's a sample for response question that tests your understanding of arrays and array lists and traversing arrays and array lists. For this particular example, you're going to be looking at arrays, not array lists, and that's Hall is an array. So that's the example of the array itself. But basically, let me just kind of walk you through what you're supposed to be doing, just in case when you read this you weren't quite sure what was being asked of you. You do have an array right here, 1 1 2 2, that is supposed to symbolize, I guess you can think of it as a hallway, where each little tile represents an object, a toy, for example, that needs to be picked up. And the little arrow is the location of a robot that is going to pick up all the toys in this hallway. Now, if this little arrow right here is pointing to the right, that means that the robot is facing to the right. And what happens is that the robot right now is in this tile, which is location 1. So the index of the array is 1. And if there's a toy in this tile, the robot will pick up the toy symbolically. As far as what we're concerned, that means that we need to subtract 1 from the element of the array at this location. And so after in the first move, you would subtract 1 from that location. And because there's no more tiles or no more toys at this location, after you subtract 1, you move to the right because the robot is facing to the right. And then you get to the second tile and you remove a tile. I keep saying tile. You remove the toy, one of the toys, so you go from 2 toys to 1 toy. Now, because there's still 1 toy there, you remain in that location. And in move 3, you remove that toy, and now you're at 0. And so when you're at 0, you move to the right 1 slot, and so on and so forth. And the objective is to end up with zero toys, no toys at all. So you're basically subtracting from every element one at a time until you get to an array that has 0 for all of its elements. A thing that we must make note of and that we're going to have to program is when we reach a wall, if you will, the right wall, or when we reach the left wall, we need to allow the robot to turn in the opposite direction. So if the robot is facing to the right, and right here where you would remove this tile, so this toy, you remove the toy, so now you have 0 toys. You try to move to the right, but you can't because the wall's right there. And so instead of moving to the right, you're gonna turn and face to the left, which is right here. And then you would progressively move to the left because there's no toys anymore until you get to the first tile right here in the hallway. And you remove that last tile right there. You try to move to the left, you can't because the wall's there, and so all you end up doing is turning right. And at this point, the program ends because the hallway is clear. And so there's a few things that we're doing every single time. First, we're checking to see if there's toys at our current location, and if there is a toy, we want to subtract 1 from whatever value is there. And after we subtract 1, we want to check to see if we can go to the right, and if we can go to the right, we move right. And at the same time, we want to check to see if the hallway is cleared. So all those things we want to do every single time. Now you are given the skeleton of the robot class. There are 3 instance variables. One of them is an array. Hall is an array. Position, that's the current position of the robot. And this Boolean variable, which is true or false, which denotes whether you're facing right. And so if facing right is true, then the robot is facing to the right. If it's false, then the robot is facing to the left. And you're responsible for coding 3 methods in here. The forward move blocked, the move method, and the clear haul method. So 3 methods. There's one method, haul is clear, whose implementation is not shown, but we are going to have to code it because we're testing all these methods. Now I want you to notice something, and this has to do with some of the questions and comments that were made. What's the difference between private and public? I've mentioned that in previous videos, but I think it stands out a little bit more in this particular example because if you notice, the only public method is clear haul, which is something that affects how you test your methods, how you test all this. None of them are declared as static methods, and so because none of these are static methods, none of them, we're not gonna be coding the main method within this class. Instead, we're gonna make a separate a robot tester class. In this first video, I want to work on making the tester class, providing a constructor, because we're gonna need a constructor to initialize all these variables, and I'm gonna initialize them so that they match this particular example. And then we are also gonna write the code for haul is clear and forward move blocked. You'll see that these 2 methods are actually pretty straightforward, but again, I do want to minimize to an extent the length of these videos, and I'll code the next part B and part C in a separate video. So let's go ahead and start here. I've already copied these. Actually, I can't copy them. They for this example, this is an image, and so I can't highlight this and paste. So I had to code it. But I have 2 files. If you need to, pause the video right now so you can copy this. One of them is the robot, which for now I've temporarily put a return statement in each of the methods that returns a value. This one, move, does not. It's void of a return, so there's no need for return. And I just made up some values. It doesn't matter what you put here, false, 0, and false. And then I have the robot tester, a separate class, where I'm gonna create a robot object. I'm calling it R2D2. For those of you who are into Star Wars, I do need to make a constructor, and so that's what I'm going to spend time doing right now. Now, the first thing I want to do is I want to give these variables haul, position, and facing right an initial value, and we do that by creating a constructor, public, and a constructor never returns anything, so we don't include the word void. We just give it a name, and the name of the constructor always has to be the exact same as the name of the class. Capital R and everything. We need 3 parameters because I'm trying to initialize 3 instance variables. The first is going to be an array of integers, and I'll just call it H, short for haul. Then just a single integer, which I'll call P, short for position. And then finally a Boolean parameter, which I'm going to call right, for facing right. And what we do with the constructor is that we can initialize these values. Notice that they're not initialized. Right here, I don't have like something like position equals 0. It's not there. Or I don't have facing right equals true. That's also not there. And that's what we do with the constructor. The constructor allows us to initialize these variables. And so we could say haul equals H, position equals whatever P is, and right equals, I'm messing these up, facing right equals whatever right is. Now, how do you know whether haul goes here or instead of here, like whether it would be backwards? Well, if I want to initialize position to like to 0 or to 1, I could do it here instead, right? I could do it in the constructor. Position equals 1. I've declared it here to be an integer, and then I can say, well, now position is 1. And then I can say facing right. Yeah, true, that's true. But doing this, what happens is every time you make a new robot, it's always going to be initialized to a position of 1 and facing to the right. Always. And that's what we use the parameters for. Instead of hard coding this number, instead of hard coding this value, we say position is whatever P is, and facing right is whatever right that parameter is. And so now I'm going to compile, and now I can go to my robot tester class, and I can say when I create this new robot, I want to send it an array of integers. Let me try doing this because I think I can hard code the array. I'm going to copy the elements straight from the example here. So 1, 1, 2, 2. 1, 1, 2, 2. Those are the elements of the array. So I'm going to put here 1, 1, 2, 2. Like that. And then the initial position of the robot is at index value 1. Okay, this is the position 0, 1, 2, 3. So at location 1, and it is facing right. So I'm going to say after I send this argument, which is an array of integers, this, by the way, is this right here is being stored in this variable. And so then haul is going to equal whatever that is. And then I'm going to send the next argument is going to be 1. That's the position, the initial position of the robot. And then it is facing right, so I'll put true. Notice that each argument, this is an array, okay? This is one argument. It is separated by a comma. And so there's a total of 3. Now I want to compile to verify that this is working fine without error. Dual start of expression. Okay, so I guess I can't do it like this, quite like this. Okay, fine. I'll just do it really quick here. I'll just make an array R equals, I'm missing the square brackets right here, an array of integers called R. And then I'm just going to send R as an argument. Good, that works fine. Yeah, I thought I was going to be able to get away with that, but clearly I wasn't. Now, let me talk a little bit about the axis, private and public. R2D2 is a robot. That means that R2D2 has the following methods. It has the forward move block, it has the move method, it has the clear haul method, and it has the haul is clear. And the way you access a method is by saying, using the name of the object R2D2 dot, and then something like move. That's one method, right? Or forward move blocked, like that. Or the clear haul, I think, is the other one. Let me check, just clear haul. Right? Or the other one, haul is cleared. But this is how you execute a method within an object. Now the problem here, and this is, I guess, to address a question, is that we cannot access private methods. And so this is a separate class. It's not. It's a separate class from the robot class. They're two different classes. And when you declare the move method as private, you're saying that a separate class cannot access this move method. And so if I try doing this, r2d2.move, and I compile, I'm going to get an error. It says move has private access in robot. And so I cannot execute the code in move from a separate class. I cannot. The only method that I can execute is the one that's declared as public, which is the clear haul. That's it. And so public, clear haul, and that's the other. Notice that the other ones are all private. Private, 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 and then we have the constructor. And so the only one I can execute is the clear hall method, like that. Now if I compile this, then I should have no errors. Good. Now what that means is that, hey R2D2, I want you to execute all the code in clear hall. And so you go to the robot class, because R2D2 is a robot, and it would execute all the code in here, just in here. Now then you say, well, what's the purpose of the other methods? And what's true is that we're going to be calling these move, forward move, and hall is clear. We're going to call those methods from within the clear hall method. We're going to do something like execute all the code in move, or execute all the code in forward move blocked. I mean, obviously this is not the implementation we want, but that's what's going to happen. Now here, if I compile, I don't have any issues, because although move is a private method, I'm executing the move method from within the robot class. And so I can execute the move method from within this class, because it is a private method. That means that you can only execute private methods within the same class, but not from a separate class. Now let's talk a little bit about the two implementations that we want to discuss for the remainder of this video. The hall is clear and the forward move blocked. Let's start with this one, which you're not responsible for, because it is not part of the problem statement. It says implementation not shown, and notice how you have part A, part B, and part C. And so you're supposed to just assume that this works as intended. It returns true if the hallway contains no items, otherwise it returns false. And that means that if every element in the array is a 0, it should return true, otherwise false. And it's easier, in my opinion, because what we're going to end up doing is we're going to traverse the array. We're going to look, okay, is this 0? And then if it's not, we're going to move on. Is this 0? And is this 0? And notice when we start, the answer is no. It's easier, in my opinion, to find, rather than check every element and verify that they're all zeros and then return true if that's true, we can check find at least one element that is not 0 and return false. So all it takes is one element, and that would be this example, this element, for one element to not be 0, and we know that we need to return false because the hallway is not cleared here, which is easier than verifying that every element is 0 and returning true. And so what I'm gonna do here is I'm gonna say I need to traverse the array, and when I say the array, I'm referring to this array, hall, because it is an instance variable. It's declared outside of any method. These are the 3 methods, 4 as a matter of fact. And because this instance variable is declared outside of the method, you can access the variable from within any method. And so I'm gonna traverse hall, and we do that using a for loop. Excuse me. We can use a for each loop or a for loop. I'm gonna say for int. Well, I guess first I need to make a variable, a Boolean variable that we can call clear, and we can say I'm gonna say it's true. You'll see why in a minute. Actually, I'm going to use a while loop. While clear is true, and you can do this, but when the variable is of data type Boolean, in which clear is a Boolean, you don't have to check to see if it's true. You can just, this right here is equivalent to just writing this. While clear is true, we want to traverse the array. If, and we'll deal with some variables in a minute, but if hall of I is greater than, not equal to, just greater than 0, then I want to set clear to false. And I'm going to start checking with the first element. So I'm going to say I is int I is equal to 0. And so that would be, hey, let's check to see if hall of 0, which is the first element in the hallway, is more than 0. And if it is, then we know that the hallway is not clear. And so we're going to set clear to false. And setting clear to false automatically is going to get us out of this loop. We're not going to keep checking. So we're going to come in here while clear is true. Clear is no longer true, it's false. And we are going to return clear. Now, the best way for me to test whether this is working or not, because I expect a false condition because these are the elements in the hallway right now. There's one toy, two toys, two toys. So it's not cleared. And so I can only execute the code in clear hall right now. That's the only code I can execute. And so I need to test, I want to test this, hall is clear. And so I'm going to test it by doing here within the clear hall method, I'm going to print what hall is clear returns when it checks the array here. I'm going to compile and I'm going to run, and it's false. And so it works. I want you to take a minute here to try to understand what's going on when, or I guess maybe I should try to explain what's going on here. This line of code, line 7, makes a new robot called R2D2, and it sends it the array. So R2D2 is going to have a hallway with these elements in it. The robot R2D2 is going to be first at location 1, where this is 0, 1, 2, and 3, and it's going to be facing to the right. And then I'm going to say, hey R2D2, I want to run your code in clear hall. And if I go to clear hall, the first line of code here says print what I get when I execute the code in hall is clear. And hall is clear is this method. And what hall is clear does is it says, okay, I'm going to say that the hallway is clear. I'm going to say it is. And I'm going to say while this variable is true, let's see if the elements in hall, which by the way is this right here, right? If any element is more than 0, then I know that there's a toy at that location, and so I'm going to set clear to false. And I loop back, and while clear is true, and it's which is not true anymore. Clear was set to false, so I exit the loop and I return false. And so this again is not required of you, but it's good practice, and we need it to test our method. Okay, so that takes care of hall is clear. Now let's look at this forward move block. For this forward move block, which is that's the first method that you're responsible for coding, let's read what it says. This method returns true if this robot has a wall immediately in front of it, so that it cannot move forward. Otherwise, it returns false. So we're going to return a value, true or false, a Boolean variable. We return true if there's a wall right in front. So like right here, if the wall right here is right in front. False otherwise. Now, there's a few things that we need to understand here. If you're facing right, then you would check this wall right here. which is basically the length of the array, right? If you're facing right and you're at the last element of the array, in this case, the length of the array minus 1, because the length is 4 minus 1 is 3, so that this location, then you would want to return true. But if you're facing left, you need to be right here, which is at 0 if your position is 0, or if your position is the length of the array. So I think I have an idea. Let's say this. I need to return true if I'm facing right, which is a Boolean variable, and so I don't have to put here equals true, and you can if you want, but you don't have to. If I'm facing right and the position of the robot, which is that variable, is equal. So if I'm facing right and I'm at the end of the array, which would be the length of the dot length minus 1, because the length of the hallway right now is 4. There's 4 tiles, but the last index value of the hallway is 3. So the length is 4. There's 4 elements, 1, 2, 3, 4. But when we are accessing elements, we use the index location, and we always start indexing at 0, 0, 1, 2, and 3. So the length is 4, minus 1 is 3. So if I'm facing to the right and the position is 3, I know that there's a wall in front right here. Or if I'm facing left and the position is 0, and we can hard code the 0, then there's a wall right here. So if this is true, I'm going to return true. I also else if I'm not facing right, which I can say I can check 2 ways. I can say facing right equals false, but there's, in my opinion, a better way. Instead of checking to see if facing right equals false, we can say if not facing right, which we can use an exclamation mark for. Not. If you're not facing right, that means you're facing left, and the position of the robot is 0, also return true. Why? Because again, forward move block is supposed to return true if you've hit a wall. Else, return false. Now this is a little trickier to test. Well, it's not actually. Let me show you how we can test this. I'm going to compile this now and verify that I have no issues. Okay, we want to print what forward move block returns. I've tested this already. The hall is clear. I actually haven't tested all cases, but I think it works for now. I'm going to copy it. Actually, you're right. Well, I'm right. Well, never mind. I came across. We didn't test the hall is clear for when it is clear. Let me take a quick step back. Let me put a 0, just full of zeros, and I expect a true for hall is clear. So run all the code in clear hall. The code in clear hall right now is to print what hall is clear returns, and right now I'm expecting it to return true because the hall is clear. Oh, let me run it one more time. Yeah, and run. Okay. End. There we go. Okay, something's obviously wrong. Let's just verify here. Let me compile this, although I see no issues here. And let me run this one more time. It's stuck somewhere, and I believe it's stuck in an infinite loop. Yes, you see here it's waiting for me to end it. There's a problem. There's a problem clearly, and I guess I thought it was good, but apparently I was not. The problem here is that we never set clear to false because this condition is never true. Hall of I, the element at Hall is never going to be greater than 0 because it equals 0. Every element is 0, so I never set it to false, and so I never exit the loop, and I'm looping and I'm stuck in there. And so what I'm going to do here is I'm going to say that there's more than one way to figure this out, but I'm going to say that if I, the index value, if we've reached an index value of hall.length minus 1. Again, the length of my hallway is 4, but the last element, the last index value is 3, so 4 minus 1 is 3. If I've reached the last location here, because this starts at 0, oh, I never incremented I. That's a good I plus plus. I was always only checking the first index value, but I suspect that that would not solve my problem. Let me try it. I believe that I would still engage in an infinite loop. Oh no, I got an index out of bounds exception, which makes sense. Eventually, so the last element I can access is hall of 3, and I'm not stopping it, right? So this has there's no reason why this is going to stop incrementing. So it's going to be 4, 5, and I'm trying to access an element that's not there. And so I am going to say here, so the last value I want to check is 3. Hall of 3, is that greater than 0? And then that means right here is going to be incremented to 4. And so I'm going to say that if I is equal, I'm just going to put greater than to be on the safe side, greater than or equal to hall.length. So the last element I want to check is hall of 3. Increment to 4. So if I is equal, greater than or equal to the length of hall, I want to set clear to false, but then I'm not going to send the true value here. Give me a minute here because I don't want to waste too much of your time. Okay, I've changed my mind. I figure the best way to do this is using a for loop. You'll see how this looks. For, and you can use a for each or a regular for loop. 0, I is less than hall.length. And of course, we've done this quite a lot of times, and you're tested, as a matter of fact, on your ability to traverse an array. So make sure that you are familiar with this. I is going to be 0, and then we're incrementing I by 1, and we're doing it until I is less than the length of my hallway, which is 4. So the last value of I that is still less than 4 is 3. And I'm just going to say that if hall of I is greater than 0, not equal to, just greater than, that means that there's some toys in this location, then I want to set clear to false. Okay, much better. We've actually done something like this in the past. I think with the while loop, I was overthinking it, and it was just taking us down the wrong path, which means that I've kind of wasted a little bit of your time on this video, but well, I apologize. Let's test it. Let's see, right here I'm expecting true. Hallway is clear, so I'm expecting true. I'm gonna run. Good. And then if I actually put the values that they have, 1, 1, 2, 2, those are the values that you start with. I'm going to compile again and then run. That's false. Good. And then just for the sake of it, I'm going to test a case where you have almost an empty hallway. False. Good. Okay. Now let's test the forward move block. We want to test this right here. I kind of feel like just making the video again, but we're already 35 minutes in. So it was, my implementation with the while loop just took too much time and I ended up getting rid of it. But okay, we're almost done here. Okay, now I want to test this code. I want to see if this code is working, which means that I want to execute this method, but I cannot execute this method from here. I cannot do this because the method is set to private. And so I can't do this. What I can do is execute the clear hall method. And so in the clear hall method, I can just say, hey, let me execute all the code here in the move forward block and print what it returns to me. So let's see what this returns to me by printing it. Now, position is right here. Facing right is right here. These are variables. They are initialized by the constructor. And so they're initialized right here. And so if I want to test, let me compile here. If I want to test this, I want to set my position, which is the second argument that is stored in the second parameter here. Excuse my going back and forth. So this is the position, and then this is whether I'm facing right or not, right? Second parameter, third parameter. And so my second argument and third argument, the way I'm going to check this is by saying I'm expecting true when I'm at 0, 1, 2, 3, at location 3, and I'm facing right. So I'm going to put a 3 here and then true. And I'm going to compile and run. And so I get true. Nice. Now the other location where I'm expecting a true is at location 0, but I'm not facing right. I'd be facing left. And so I'm going to put here 0 and then false. So I'm expecting true as well. Good. Now let's test what we had initially. And this should be false. At location 1, facing to the right, so I'm not at a wall, this should be false. Good. I can test more, but we're already at 38 minutes, and so I'll leave it at that. If you have questions, let me know. On the next video, I'll go over part B and part C of this for response question.